everyone! Welcome to episode number 641 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. Folks, I am happy to bring in Jan Zimmerman from TEWS Technologies this week. Jan and I are talking all about VITA 93, a new QMC mezzanine card standard, and why scalability, modularity, and flexibility are central elements of this new standard. Jan and I also discussed the unique I/O capabilities of QMCs and how TEWS Technologies is furthering innovation in this arena. So, without further ado, please welcome Jan to Fish Fry. Hi, Jan. Thank you so much for joining me.
Hi, Amelia. Great to be here with you on the fish fry.
Excellent. Okay, so first off, tell my audience about TEWS Technologies.
Sure. TFS Technologies was initially founded in 1973 near Hamburg in Germany as a family-owned business, and up to today still is a family-owned business. So we're looking back on over 50 successful years of experience in the embedded I/O market. And being in business for such a long time, I think it's fair to say that we are one of the leading manufacturers of embedded I/O solutions. We pretty much do develop everything from COTS products, modified COTS products, and of course also do custom design solutions. Having our own software team is also a great benefit as it allows us to build device drivers for our products to make it easy for the end customer to either use or integrate our products. And besides hardware and software engineering, we of course also have our own firmware development team that creates custom firmware, for example, for custom designs. I think what we're most proud of here at TFS is definitely our quality. Quality is really the core of our DNA and our key to success. We're certified to ISO 9001 and AS 9100, the space and aircraft norm, and we test every single board that leaves our premises with both an electrical and a functional test, allowing us to not only give 2 years of standard warranty, but instead 5 years. And also recently, we have made some big steps forward. We celebrated our 50 years anniversary. We moved into our new headquarters, and we also successfully managed our succession where Tim and I took over the company from our fathers. So yeah, I think we're in a great position for the future.
Fantastic. So we're talking about VITA 93.0 QMC small form factor mezzanine solution today. So first, Jan, what are we looking at when it comes to the size and height of this solution?
Yeah, first off, a QMC card itself is pretty small. A single QMC comes with a base size of 26 millimeters times 78.25 millimeters. And when taking into account the shrinking IC package sizes we currently see, I think this is a great size. The small size allows us building single function modules without wasting PCB area, and in addition, carriers can easily provide multiple QMC sites, which allows system integrators to comply with their customer requirements by just plugging in one or more QMCs depending on what their customer really needs. And when you ask for height, the standard component height we use with the QMC is 4.7 millimeter, which is well known from PMC and XMC and has proven sufficient for most circuit designs there. Also, these traditional mezzanine concepts like PMC and XMC usually come with a fixed stacking height, often forced by the fact that the mezzanine provides all the mounting hardware. And this usually works well for systems that match the stacking height, but is a huge drawback for systems that would allow for more stacking height. And here is where the QMC comes into play, because the QMC allows for difference stacking heights. It's either 9, 11, 14, or 16 millimeters, which is great as the variable stacking height maximizes the component envelope on the carrier, for example, on CPU boards or SBCs, resulting into additional available space on the carrier that would not be available with the use of traditional mezzanine concepts.
So, Jan, scalability is an important aspect of this VITA standard, right? So, talk to me about that.
Yeah, it indeed is. Scalability is actually one of the key benefits of QMCs. In the beginning, I already mentioned the base size of a single QMC. And when talking about scalability, the QMC can scale up from a single to a double, a triple, and a quad QMC, either doubling, tripling, or quadrupling the available space. What's important here is that the QMC not only scales with size, but also with power, connectivity, bandwidth, and I/O count. To give you an example, let's say we have a single QMC. A single QMC comes with 40 I/Os and a PCIe X4 link. A double QMC would have twice as much I/O as well as an X8 link, so 80 I/Os, X8 link. And we can easily continue that for triple and quad QMC. So triple QMC would have 120 I/Os and an X12 link, a quad QMC 160 I/Os and an X16 link. So you just need to keep in mind the single QMC and multiply it by 2 for double, 3 for triple, and 4 for a quad QMC. A quad UART, for example, will for sure fit on a single QMC, while a large system on chip, on the other hand, we would need most likely a triple or even a quad QMC. So scalability allows us to use the standard for a whole range of applications, starting from simple I/O functionality on a single QMC, like the quad UART design I just mentioned, up to the highest complexity solutions with the need for example, high bandwidth and high I/O count on, for example, a quad UART design. And another cool thing about QMC is that carriers can be populated with various combination of single, double, triple, and quad QMCs, only limited by the amount of QMC sites and PCI Express connectivity provided by the carrier, of course. So the same carrier could, for example, be populated with 4 different single QMCs in case the customer needs a broad range of different I/O interfaces, or with 1 quad QMC when the customer demands for high power and highest performance. And of course, all other combinations like 2 double QMCs or a single and a triple, that would also be possible. The key advantages of QMCs can therefore really be summarized in 4 simple terms, which is the scalability, its modularity and flexibility, and the rugged and reliable design. And I think here you can really see that the standard was built on lessons learned from previous standards, combining the best features of earlier form factors while introducing new capabilities as well.
Fantastic. Now, also talk to me, Jan, about the I/O capabilities here.
Sure. First, we're talking about modular I/O concept, addressing requirements for higher bandwidth, greater flexibility, and scalability. So when talking about a single QMC, it provides 20 differential pairs that can also be used as 40 single-ended I/O signals. In addition, there is 1 ground pin for each I/O, and this is critical for the signal integrity of high-speed interfaces that we can therefore realize with QMCs. The I/Os are organized in 5 I/O pipes, where each I/O pipe consists of 4 differential pairs and their individual ground. That means that each I/O pipe has its own ground reference plane, and this structure of an individual ground for each I/O pipe allows us to also support isolated interfaces like 10G Ethernet. So this is a large improvement for the system. And also, these defined I/O pipes are supposed to provide a little bit of structure during design and usage of the QMC modules.
That makes sense. Now, Jan also talked to me about cooling here. This solution is conduction cooled, right?
Yeah, I guess the answer to that question would be yes and no, because QMCs are not only available as conduction cooled boards, but also as air cooled boards. Unlike previous mezzanine concepts with QMC, the air cooled and conduction cooled version can be realized on the same PCB, which is a great advantage. And when generally speaking about the cooling concept of QMCs, there's one simple rule, and that is that the carrier or the carrier manufacturer provides all the mounting hardware. So if you imagine an air-cooled setup, you would have your QMC carrier with already mounted standoffs, and then also spacers that do cover the space for a potential heatsink of the QMC. And this is really special with the QMC because this allows mounting both an air-cooled QMC or a conduction-cooled QMC on an air-cooled carrier board. In the conduction-cooled setup, on the other hand, you would have a QMC with an already mounted Skyline heatsink, which, by the way, is the only mechanical part that will probably ever come together with a QMC. And then you have that QMC with its Skyline heatsink that you would then mount on the conduction-cooled carrier. In both cases, the design of the carrier cooling structure is 100% up to the carrier designer, as long as the mechanical envelopes are not violated, of course. After all, this is a very well thought through concept that not only makes it possible that every QMC will always fit on every carrier, but also ensures interoperability between vendors. And I think after hearing all that about the new standard, I'm pretty sure people wonder, where does it fit into the current ecosystem, right? So I personally think that QMC is an ideal fit for almost all application and industries because of its modularity, flexibility, scalability, and also because of its potential to cover rugged designs. So to summarize it with the VITA 93 standard, we have created a new standard that has been developed for the growing demands in the embedded system market for modular I/O, addressing requirements for higher bandwidth, greater flexibility, and scalability that was built on lessons learned from previous standards, combining the best features of earlier form factors while introducing new capabilities to not only meet the challenges of today, but also for tomorrow.
Fantastic. All right, Jan, it is time for your off the cuff question. So, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
Oh, well, that's a tough question. I think I can't even decide for a specific meal, but I'll definitely know where I would take that in.
Sure.
Yeah, I think probably to a restaurant called Christie Hills. It's near Lake Tahoe.
Oh,
Yeah, the food there was excellent and the view as well. I've been there with my wife for our honeymoon, and yeah, we've seen the most beautiful moonrise ever together there. So yeah, I'll definitely go there again.
what a good choice. I have been to that restaurant. I know exactly what you're talking about. What a perfect choice. Well, Jan, I think that's all I have time for today. Thank you so much for joining me.
Yeah, thank you for having me.
Well, folks, that's all I've got for this week's Fish Fry. But I've got some super cool interviews lined up for the rest of the summer, including my chat with Wenzi Jin from MathWorks about shift left and the rise of software defined vehicles. My discussion about the challenges of open source development with Julie Chen and Tim Jurovich from Deloitte, and more. So make sure that you subscribe to this here podcast on Spotify, Podbean, Apple Podcasts, YouTube, or just about any other podcasting platform to listen to these and other exciting upcoming episodes. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If LinkedIn is more your thing, you can follow us or me on LinkedIn as well. And we are also on Blue Sky Social and Mastodon too. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and our animated series called Libby's Lab. And of course, you can subscribe to our EE Journal YouTube channel as well. Thank you, everyone, for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of July 18th, 2025, I'm Amelia Dalton, and you've been fried.